Have you ever looked at a computer and thought, how does it all work? It's like a magical box full of complicated stuff, right? But don't worry, you're not alone. I'm here to break down the basics of computers in a way that anyone can understand. We'll go step by step using simple language and examples. By the end, you'll have a much better grasp on these amazing machines. So, are you ready to demystify the digital beast? Let's jump. At its core, a computer is a machine that processes information. You give it instructions, it follows them, and spits out the results. Think of it like a very obedient chef. You give the chef a recipe, instructions, and ingredients, data, and they cook you a delicious dish, output. Computers come in all shapes and sizes, from the tiny ones in your smartwatch to the massive ones used in research labs. But they all share the same basic components that work together to get things done. We'll learn about these components in the next few. The CPU, or Central Processing Unit, is like the brain of your computer. It's the part that carries out all the instructions you give it. Imagine the CPU as a conductor of an orchestra. The conductor reads the sheet music, instructions, and tells each musician, computer component, what to do and when to do it. The CPU has two main parts, the Arithmetic Logic Unit, ALU, and the Control Unit. The ALU does all the math and logic operations, while the Control Unit fetches instructions from memory and tells other parts of the computer what to do. Now let's talk about memory. Memory is a crucial component of your computer, and it comes in various forms, each serving a unique purpose. Understanding these different types of memory can help you appreciate how your computer processes and stores information. Your computer has two main types of memory, RAM and ROM. These two types of memory work together to ensure your computer runs smoothly and efficiently. While they both store data, they do so in very different ways and for different purposes. RAM, or random access memory, is like your computer's short-term memory. It temporarily holds data that your computer is actively using or processing. This allows your computer to access this data quickly, which is essential for running applications and performing tasks. It stores data that the computer is currently using. For example, when you open a web browser, the data needed to display the web pages is loaded into RAM. This makes it possible for you to switch between different applications and tasks without experiencing significant delays. Think of it like a whiteboard. A whiteboard allows you to jot down notes quickly, make changes, and erase information as needed. Similarly, RAM provides a space for your computer to temporarily store and manipulate data. You can write things on it quickly, erase them, and write new things. This flexibility is what makes RAM so vital for multitasking and running complex applications. However, it's important to note that the data in RAM is volatile, meaning it is lost when the computer is turned off. ROM, or read-only memory, is like your computer's long-term memory. Unlike RAM, the data stored in ROM is non-volatile, meaning it remains even when the computer is powered down. This makes ROM ideal for storing firmware and other critical instructions. It stores permanent instructions that the computer needs to boot up. These instructions, often referred to as firmware, are essential for initializing hardware components and loading the operating system. Without ROM, your computer wouldn't know how to start. This is like the information etched onto a stone tablet. Just as the inscriptions on a stone tablet are meant to last, the data in ROM is designed to be permanent and unchangeable under normal circumstances. It's always there and doesn't disappear when you turn off the computer. This permanence ensures that your computer can reliably start up and function correctly every time you power it on. Together, RAM and ROM form the backbone of your computer's memory system, each playing a crucial role in its operation. Section 5, HDD versus SSD. Where does your data go? When you save a file, it needs to be stored somewhere, right? Whether it's a document, a photo, or a video, your computer has to find a place to keep it safe and accessible for future use. This is where storage devices come into play. They are the unsung heroes of the digital world, ensuring that all your precious data is securely stored and easily retrievable whenever you need it. That's where storage devices come in. These devices are designed to hold vast amounts of data, from tiny text files to massive video files. They come in various shapes and sizes, each with its own unique features and capabilities. But among all these options, two types stand out as the most common and widely used: HDDs and SSDs. The two most common types are HDDs, or hard disk drives, and SSDs, or solid-state drives. Both serve the same fundamental purpose of storing data, but they do so in very different ways. Understanding these differences can help you make an informed decision about which type of storage is best for your needs. An HDD is like an old record player. Imagine a vinyl record spinning on a turntable with a needle moving across its surface to read the music. Similarly, an HDD has spinning disks, known as platters, and a read-write head that moves across these platters to access or store data. This mechanical process is what allows HDDs to store large amounts of data at a relatively low cost. It has spinning disks and a needle that reads data. The platters are coated with a magnetic material, and the read-write head uses magnetic fields to change the data on the disk. This technology has been around for decades and has proven to be reliable and cost-effective for many users. An SSD, on the other hand, is like a USB flash drive. Instead of relying on moving parts, SSDs use flash memory to store data. This makes them much faster and more durable than HDDs. Flash memory is a type of non-volatile storage that retains data even when the power is turned off, ensuring that your data is always safe and accessible. It has no moving parts and stores data on flash memory chips. These chips are arranged in a grid, allowing for quick and efficient data access. This lack of mechanical components means that SSDs are less prone to physical damage and wear and tear, making them a more reliable option for many users. SSDs are much faster than HDDs. They can read and write data at incredible speeds, significantly reducing the time it takes to boot up your computer, load programs, and transfer files. This speed advantage is one of the main reasons why many people are making the switch from HDDs to SSDs, but they're also more expensive. The advanced technology and superior performance of SSDs come at a higher cost. However, the price of SSDs has been steadily decreasing over the years, making them more accessible to a wider range of users. It's important to weigh the benefits of speed and reliability against the cost when deciding which type of storage to use. If you want your computer to boot up quickly and load programs faster, an SSD is the way to go. The improved performance can make a noticeable difference in your daily computing tasks, from browsing the web to editing videos. Ultimately, the choice between an HDD and an SSD depends on your specific needs and budget. Both have their own advantages and can serve you well in different scenarios.
Imagine building a powerful gaming PC or upgrading your computer, but you're stuck because you don't understand the motherboard. Don't worry, because in this video, we'll break down everything you need to know about motherboards, their components, and how they impact your PC's performance. Stay with me till the end, and you'll be a motherboard pro. A motherboard is the main circuit board of a computer that connects all essential components, including the CPU, RAM, storage devices, and peripherals. Think of it as the central hub that allows all hardware to communicate. Understanding its layout is crucial for both building and upgrading a PC. Let's break down the key components of a motherboard. 1. CPU socket. This is where the processor is installed. Different motherboards support different CPU sockets, so compatibility is crucial. 2. RAM slots. These slots hold your computer's memory modules. More slots and higher speeds mean better multitasking. 3. PCIe slots. These are used for expansion cards like graphics cards, sound cards, and Wi-Fi adapters. 4. Storage connectors, SATA ports for HDDs and SSDs, and M.2 slots for high-speed NVMe SSDs. 5. Power connectors, essential for providing power to the CPU and motherboard. 6. I/O ports. These include USB ports, HDMI, audio jacks, and Ethernet ports for connecting peripherals. Motherboards come in different sizes, known as form factors. The most common ones are ATX, full-sized with multiple expansion slots. Micro ATX, a smaller version with fewer slots. Mini IDX, compact and ideal for small builds. When selecting a motherboard, consider these factors. 1. CPU compatibility. Ensure the motherboard supports your processor. 2. RAM support. Check the number of slots and maximum RAM capacity. 3. Expansion slots. More slots mean more upgrade options. 4. Connectivity. Look for USB ports, Wi-Fi, and Bluetooth if needed. 5. Future upgradability. A good motherboard should allow for future upgrades. Now that you understand the basics of motherboards, you're ready to make an informed decision for your next PC build or upgrade. If this video helped you, make sure to hit that like button, subscribe for more tech insights, and leave a comment with any questions you have. Thanks for watching, and I'll see you in the next video. Ever wondered why your computer suddenly slows down, crashes, or even shuts off? It might not be your software, but rather a power or cooling issue. In today's video, we're diving deep into the power supply and cooling system of computers, explaining how they work, why they matter, and how you can optimize them for peak performance. Stay tuned till the end for expert tips to keep your PC running cool and stable. Welcome to Computer Minds, where we simplify technology for you. If you're new here, make sure to subscribe and hit that notification bell so you never miss our tech insights. Now, let's get started. This video will run for approximately 10 to 12 minutes, ensuring you get all the essential details without any fluff. What is a power supply unit, PSU? It converts AC power from the wall into DC power usable by computer components and supplies stable voltage to the motherboard, GPU, CPU, storage devices, and fans. There are different types of PSUs: non-modular, semi-modular, and fully modular, each with its own differences and benefits. Power ratings can range from 400W to 1000W plus, and choosing the right wattage is crucial. The 80+ certification, bronze, silver, gold, platinum, indicates efficiency ratings. Common power issues include insufficient power leading to crashes and freezes, risks associated with cheap PSUs like power fluctuations, component failure, and even fires. You can calculate the required PSU wattage using online PSU calculators. Why does cooling matter? Overheating can throttle CPU/GPU performance, shorten hardware lifespan, and cause system crashes. Heat dissipation ensures smooth multitasking in gaming. There are two main types of cooling systems: air cooling and liquid cooling. Air cooling includes CPU heatsinks and fans, with stock versus aftermarket coolers like Noctua and Cooler Master, as well as case fans for proper airflow setup, intake versus exhaust. Liquid cooling options include AIO, all-in-one, and custom loop, each with its pros and cons. Best cooling practices involve cleaning dust regularly from fans and heatsinks, applying thermal paste correctly, positioning fans for optimal airflow, and monitoring temperatures with software like HW Monitor and MSI Afterburner. Invest in a high-quality PSU from trusted brands like Corsair, EVGA, or Seasonic. Use a UPS, uninterruptible power supply, to prevent power surges. Upgrade your cooling solution if you overclock your CPU or GPU, and keep your PC in a well-ventilated area to avoid heat buildup. And that's everything you need to know about power supply and cooling systems in computers. Now it's your turn. What's your current PSU wattage, and are you using air or liquid cooling? Let us know in the comments. If you found this video helpful, don't forget to like, share, and subscribe for more awesome tech content. Thanks for watching, and I'll see you in the next video.
Section 8. Building your own PC, a step-by-step guide. Now for the fun part. Building your own PC can be an incredibly rewarding experience. Not only do you get to customize every aspect of your machine, but you also gain a deeper understanding of how computers work. Building a PC might seem daunting, but it's like putting together a Lego set with instructions. Each piece has its place, and with a bit of patience, you'll see it all come together. First, you'll need to gather all the components. A case, which will house all your parts and provide the necessary structure. Next, you'll need a motherboard, which is the main circuit board that connects all the components. The CPU, or central processing unit, acts as the brain of your computer, processing all the instructions. RAM, or random access memory, is crucial for multitasking and running applications smoothly. You'll also need a storage device like an SSD or HDD to store your operating system, games, and files. The PSU, or power supply unit, provides the necessary power to all the components. And of course, a graphics card is essential if you're a gamer, or if you plan on doing graphic-intensive tasks. It handles rendering images, videos, and animations. Then, you'll carefully install each component onto the motherboard, ensuring everything is securely in place. Connect all the necessary cables, making sure to follow the instructions provided with each component. Once everything is connected, you'll place the motherboard inside the case. Secure it with screws and make sure all the components are properly aligned. There are tons of online tutorials and videos to guide you through each step. Websites like YouTube and forums dedicated to PC building are invaluable resources. Just take your time, be gentle with the components, and double-check your connections. It's important to be patient and methodical to avoid any mistakes. And before you know it, you'll have a brand new custom-built PC that you can be proud of. Not only will it be tailored to your specific needs, but you'll also have the satisfaction of knowing you built it yourself. Section 9. Unleash the power of computing. Congratulations! You've reached the end of this crash course on computer basics. You've learned about the different components, how they work together, and even how to build your own PC. But this is just the beginning. There's a whole world of amazing things you can do with computers, from coding your own apps to creating stunning digital art. So, keep exploring, keep learning, and most importantly,